Hey guys, we're going to take a look at lesson 2 again. I had, showed you guys how to work these out yesterday a little bit, but we're going to do some more examples. So example 1 is just basic stuff that you should know how to do already. Basic multiplication, cross-canceling of monomials. So when you have monomials, you can cross-cancel any part of them. Like 21 and 14 have a common factor of 7. So 7 times 3, 7 times 2. Y goes into y squared, and you're left with a y up there. And then if you cross cancel on the other side, 10 and 15 have a common factor of 5. So 5 times 2 and 5 times 3. And x squared goes into x cubed, leaving you with x here. When you're done, you multiply. 2 times 2y is 4y over 3 times 3x is 9x. And that's your simplified answer. There are examples like this in your homework, in the beginning of your homework, which I skipped. Make sure you know how to do them. The answers are posted. Maybe do a couple, skip around a little bit in the beginning portion of the homework assignment. Okay, so example 2 is where you get to the new stuff. In these types of examples, you now have binomials involved. So you'll have monomials still, but you'll also have binomials. So all binomials have to be factored. That's the main idea, is factor all binomials and trinomials. Because the only way you can cross cancel is if they have common factors. So 8x cubed, I'm going to bring it down because it's a monomial. That can't be factored. But I can factor 9x squared minus 1. That's difference of squares. So that would be 3x plus 1 times 3x minus 1. And this is being multiplied by 3x minus 1 can't be simplified. It can't be factored. It's already prime. And 12x squared is a monomial. That can't be factored. So now I cross cancel the two matching binomials. 3x minus 1 and 3x minus 1 are common factors. And then the monomials will cross cancel with each other. So 8 and 12 have a common factor of 4 times 2 and 4 times 3. And this x squared will go into two of those x's, leaving you with an x in the numerator. So in the numerator, I now have 2x times 1, which is 2x. And in the denominator, I have 3x plus 1 times 3, and I write it like this. You put the monomial in front, and you leave it again in factored form. Factored form means you leave it without multiplying so that the person can see that nothing else can be simplified from there. Okay, so we're going to do a couple more of these. Here's another one. This one has a little twist in it, which is that when you look to factor the first binomial, negative 8x minus 16, and you want to pull out a GCF, instead of pulling out the number 8, it would be better to pull out the number negative 8. Sorry, let me change this. If you pull out a negative 8, it'll make it easier because now in your parentheses you have positive x. It's always easier to have a positive x or positive x squared. So if I pull out a negative 8 times x would be negative 8x, and then this would have to be a positive, right? Because negative 8 times positive 2 would be negative 16. And now my denominator is difference of squares, so that's going to become x plus 2 times x minus 2 times, and I don't have anything that can be factored in the second fraction. So now I'm going to cross out matching factors. X plus 2 can cancel with x plus 2. X minus 2 can cancel with x minus 2. And the monomials can cancel. 8 goes into 8 once, and that's all. So what's left in my numerator is negative 1, and in my denominator is x. So negative 1 over x. Okay, now we're going to move on to division. In division, you just have to remember that we multiply by the reciprocal. So if you think about regular fractions, if you had like 2/3 divided by 5/10 or something like that, this would be 2/3 times 10 over 5. Right? The multiplication, the division changes to multiplication, and you take the reciprocal of the second fraction. So that's what we're going to do here. We're going to set up for ourselves the first fraction stays the same. and I'm going to change the multiplication and take the reciprocal of the second fraction. Okay, always the reciprocal of the second one. And now I'm going to try to factor wherever I can. My numerator is a monomial. Monomials can't be factored. In the denominator here, I have a GCF definitely of 4. I'm wondering if not 4, sorry. I have a GCF of 2, I guess. I'm wondering if I made a mistake here. Let's see. 2 times 9x squared minus, no, that's right, minus 2 times 16. I gotcha. Okay, I know what I was thinking. In my second fraction here, I have, my numerator has a GCF of 4, 8 times 3x plus 4. Okay, my denominator cannot be factored. So I have one more step though, because this is difference of squares. So I'm going to factor that. I can just do it here into 3x plus 4 times 3x minus 4. Okay, now I can cross cancel common factors. So I have 2 goes into 8 4 times. Those are monomials. 3x plus 4 can cancel with 3x plus 4. And the monomials 10 and 15 have a common factor of 5. So 5 times 2, 5 times 3. And x squared can divide into x to the 4th, and that's going to, x to the 6th rather, is going to give me x to the 4th because we subtract exponents. In my numerator, I have 3x to the 4th times 4. Since they're both monomials, I do multiply them. I have 12x to the 4th. In my denominator, I have 2 times 3x minus 4. Now, sometimes this happens where you're at the end and you realize, which I'm realizing now, that you could have cross-canceled a little bit more. I could have cross-canceled this 2 with this 4, and I missed it. So I see it now, though. 2 goes into itself once, and it goes into 12 6 times. So you could have done it back here, or you could do it here. And your final answer is going to be 6x to the 4th over 3x minus 4. This cannot be simplified any further because, as we were saying, 3x minus 4 is a binomial. 6x to the 4th does not go into 3x minus 4. It's not a factor, so we leave it. Okay, basically binomials can only simplify with other binomials and monomials with monomials. That's like a little rule to remember. All right, and we're going to do one more. Example 6. It's division again, so I'm going to switch this to multiplying by the reciprocal. So it'll be 2a squared plus 14a plus 20 over a squared plus 4a minus 60 times, and I'm taking the reciprocal, 108 minus 3a squared over a squared plus 11a plus 30. And I'm going to factor. I have in the first fraction in the numerator, I have a GCF of 2. So 2 comes out times a squared plus 7a plus 10 over, denominator doesn't have a GCF. I'm going to go straight into 2 binomials. I have a times a, and 6 times 10 is 60 with a positive on the 10 and a negative on the 6. In my next fraction, the numerator has a GCF of 3. 3 times 36 minus a squared. My denominator here does not have a GCF, so it would be a times a and 3 times, no, not 3 times 10. 6 times 5. So it'll be 6 times 5. I need positive on both. I'm not going to cross cancel yet because I see I still have this can be factored into 2 binomials. This one can be factored into difference of squares. So I'm going to do another step here. I have 2 times, and then break the numerator up into 2 binomials. It'd be 2 times 5 both positive, so a plus 2 times a times 5. I'm going to copy my denominator, times, and then we have difference of squares. We have 6 plus a times 6 minus a. And then the denominator I copy. And now I'm going to cross things out. So I'm going to cross out common factors. I have a plus 5 cancels with a plus 5. I have a minus 6 and 6 minus a, which are opposite factors. They give me negative 1. So I'm going to pop a negative 1, that's multiplying in the front. And I have 6 plus a and a plus 6. Remember, these are not opposite factors because they're addition. They're identical. A plus 6 and 6 plus a just cancels to 1. And it looks like that's all that can cross out. So in my numerator, I have negative 1 times 2 times 3. All the monomials can get multiplied. That's going to give me negative 6 times, I also have a plus 2. Remember, don't distribute it, leave it. And then in my denominator, I have a plus 10. And nothing can be simplified here, right? Because you have binomials. A plus 10 does not match with a plus 2. There are no common factors. That's it. All right, so you'll have a couple of these for homework, and we will continue practicing for another day or two on this. Okay, thanks. Bye.